All right, today we're going to start the last chapter, chapter 8. Chapter 8 deals with variables, equations, relations, uh, functions, equations of lines, the whole algebra of math. Some of the stuff's going to be quick and easy. Some of the stuff is going to be long and drawn out, like series and sequences. So I'll do as far as we can today, and then we'll finish up next week. I was hoping to finish up everything today, but not going to happen. So the first section, variables. What are variables? Why? How are they important? Why do we need them? What are variables? Okay, what do you mean placeholder? Not, yeah, it could be that if you had 3 plus a number equals 7. Yeah, so since the place that we're trying to hold is this empty space, we put a variable there. What forms do variable have? Usually letters, but they could be pictures. They could be images. So, like, for example, we have X here. We could have also put 3 plus A equals 7, or 3 plus Shamrock equals 7. A variable is just that. It means it could take on any value. What is an equation? An equation is really two mathematical statements that are equal. Hence the equa part of equation. This is a statement. This is a statement. Don't believe me? How would you read that? In words, how would you read this? 3 plus X. That's a statement. That's a sentence. 7. That's a statement. It defines a number. So those are two statements that are equal. So what we have to do in mathematics, because mathematics in reality is not this. Very rarely in the real world does somebody come up to you and say 3 plus X equals what? No. They'll say, I have a problem. Can you solve it? And you have to break it down into from this. You have to put it into math and then solve it. That's the real world. So what we should do ever since elementary school, and we do, elementary school is all of the problems you see pretty much are all word problems. But somewhere along the way, usually fifth, sixth, seventh grade, we start going away from word problems and start going to just start. I'll give you this, you tell me the answer, which doesn't do any justice to anybody. Because by the time you go to college, you don't know how to do word problems anymore. Everybody hates them because they're not used to them. So what we have to do is we have to learn how to translate the statements into equations. That's the problem. And I do apologize not having the example sheets for you this morning. So I'll write these. I'll get to these next time. So example one says, in each of the following descriptions, translate the given information into a symbolic expression involving variables. Here they are. So go ahead and translate that into math, each one of those. You don't have to write them all down. You take a picture of it. But go ahead and just translate them as you read them. Don't write them all down because I don't want to keep it up there that long. So how would you do the first one? What would the first one be? Mm-hmm. Because it's $40 a day, and you're keeping it for X number of days. We don't know how many. Typically, for this one, make it easier for us, we'd use the variable D for days. Very good. Okay, how about the next one? The distance a car traveled at a constant speed of 65 miles an hour for any number of hours. Mm-hmm. 65x or 65h. Now, why would that give us a distance? Why would that equation there give us a distance? But she didn't tell me why the end result's gonna be distance, miles. And here's part two of what people forget to do because we're not used to word problems. Yeah, you're absolutely correct. What you guys said correct. So we said 65 miles per hour. A distance equation is distance rate times time. Whenever you deal with anything that moves, that's the distance problem. Rate, this one is miles per hour. And the time was in what units? Hours. So the hours cancel. What are we left with? Which is the distance unit. So that's whenever you deal with word problems, you have to be sure to worry about the units also. Because if the units don't match with what the question is asking for, it's not right. The next one. One weekend, a store sold twice as many 8 gig flash drives as 64 gig flash drives, and 25 256 drives than 8 gig drives. If the store sold D64 drives, how many 256 gig drives and 8 gig drives did it sell? So start translating what that says to you. Yes, staring at it is not a good method. You have to write stuff down. as you read it. As you read sentence by sentence, what does it tell you? You cannot attack the whole thing at one time. You have to attack it piece by piece. So did you put labels in all these things? Instead of writing 8 gig, 16 gig, 34, whatever gig, what was the first thing you want to do? The first thing I want to do, this is in C, I would say X equals 8 gig, Y equals 64, and Z equals 256. Because that way I don't have to keep on writing all this. I can just refer to X, Y, and Z. So that's the first thing to do. You have to label the variables that you have in your equation. All right, let's break it down piece by piece by piece. What does it tell? What's the first sentence tell you of this thing? Okay, so how would you put that in an equation? It sold twice as many 8 gigs as 64 gigs. How would yeah, so X is equal to 2 times Y. That's the first thing it tells us. What's the next thing it tells us? And 25 fewer 256 drives than 8 gig drives. Equals what? You can't just say that's something. You have to have it equal something. What does it equal? Yeah, because the 8 gigs are X and there's 25 fewer of these than these. But think about it. It'd be the other way because it wouldn't be equal that way. Because then you'd say that there are more 256s than the 8s. So to make these two equal, this one and this one, and these are less. So what do I have to do? I have this Z is equal to 8 minus 25. Right, so it's Z is equal to X minus 25. So there's so 25 fewer of these than these. To be equal, either have to add 25 to this one to make them equal to that, or subtract 25 from that one. If the store sold D 64 gigs, how many of the other two did it sell? It sold D 64s. So what are we solving for here? Since we know we sold D number of 64 gigs, all we know is that it has to equal Y. So how do we do that? So we know that the 8 gigs equals 2 times D. The 256 gigs is X minus 25. What's X? Yeah, so this one is Z is equal to 2D minus 25. So there we have our 3 equations. Once we have D defined, then we find the rest of them. So we know that D is equal to Y. Anywhere I see a Y, I put a D in its place. Since X equals 2D, anywhere I see an X, I put a 2D in its place. The last one. French fries have about 3 calories apiece. A hamburger has about 250 calories. Mateo is on a diet of 1,200 calories per day. If he ate F French fries and 1 hamburger, how many more calories can he consume that day? Yeah, so the number of calories is the number of hamburgers you can eat plus fries. You're right. So it's 1,200 calories here. And the hamburger was 250, and each fry has 3 calories. So how many more calories can you have a day? Or how many fries can you eat? What's the first thing we do? Subtract 250 from both sides. We want to know the, the number of fries you can eat first. Then we divide by 3. The number of fries, 3 goes into 9 3 times. 3 goes into 5 once with 2 left over. 3 goes into 6 with 2 left over. So we can eat 36 fries. And that would leave them 2/3 of a calorie left. Okay, this is the question that asks us how many fries can he eat? The question was asking how many more calories does he have the rest of that day? So if we start off with this equation here, move everything to one side, we'll get 1200 minus 250 minus and this is your equation for the number of calories remaining, depending on how many fries he ate. So the most he can eat are 300 or 316 fries, which he's not going to do that unless he's gotten big for a reason. So this tells us the number of calories left. This one tells us the number of fries he can have. All right, question number 2. This one here. A teacher asked her class to do the following. Take any real number and add 15 to it. So what are my instructions step by step by step? What's the first instruction? N is, let's say N is a number. So, or add 15 to a number. So it's N plus 15, N plus 15. You added 15 to a number. Now, multiply that sum by 4. Multiply N plus 15 by 4. Next, subtract 8. Subtract 8 from what? From what you just did. So subtract 8 from that whole thing. So multiply N plus 15 by 4 minus 8. So we have 4 N plus 15 minus 8. And divide the difference by 4. Take the above and divide by 4. So we have here is 4 N plus 15 minus 8 divided by 4. Now, subtract 12 from the quotient. What does quotient mean? Yeah, fraction. The quotient means fraction. So whatever you have in your fraction, subtract 12 from it. From the above subtract 12. So what we have here is 4n plus 15 minus 8 divided by 4 minus 12. And tell me the answer. All right, so those are your steps. What's that? Try it. Pick a number. Follow these steps. And keep the original number small so it's easier to work with. So I'm gonna pick a number, let's say 2. The formula we have is this. So order of operations, I gotta do just plug what I have inside there. I plugged in my 2 for that number there. Order of operations, do inside the parentheses first. Next, I gotta do the top. I gotta do this multiplication. So I have 17 times 4. 7 times 4 is 28. So it's 68. $68 minus 8 is 60. $60 divided by 4. Well, we know that 2 goes in there 30 times. 2 goes in there 15 times. So I have 15 minus 12 equals 3. So did y'all get one bigger than you started? Or did you get the same number? Yeah, so that's the thing. So whatever the number that the student gives you the number, you subtract 1. You said that's the number you started off with. So far, so good. So this is how you build order of operations and translating equations. So think about it. We took this entire paragraph and converted it to one equation. It's easier to write this because you put up there once and people work it out together, as opposed to having to remember each step by step by step by step by step. You build up your equation from there. Okay. The next part we're going to talk about are called sequences. What are sequences? Just a series of numbers that have a special relation with each other. There are two types of sequences. An arithmetic sequence and a geometric sequence. I'm going to put two sequences down and you'll see the difference. These are the two sequences. Do you see a pattern here? What's the pattern? Mm-hmm. Right, right, exactly. So this first pattern, I took the first number, added 3 to it, I get the second number. The second number, I added 3 to it, I get the third number. The third number, I added 3 to it, I get the fourth, and so on and so forth. What's that? Yes. So I messed up. So how did you get that sequence? You cheated. Yes, that's exactly what it'd be. Yeah. I was looking at these numbers, but these should work. 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81, and so on and so forth. So arithmetic sequence. If you look at these numbers, well, not these numbers, with these numbers, now, if you look at these, with these arithmetic sequences have what's called a common difference. What does difference mean in mathematics? Subtract. So the common difference is the numbers between all of these sets of numbers are the same. So between 4 minus 1 is 3. Between 7 minus 4 is 3. Between 7 and 10. 10 minus 7 is 3. So any two numbers I pick, the difference between them will always be the same. That's a common difference. So this first one, we call it a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth. In our sequence, here's not these guys here. A sub 1, a sub 2, a sub 3, a sub 4. It's the subscripts tell us which one it belongs to. So the first one, we added the common difference, we'll call it D, and we get the second one. So we start off with the second one. We add the common difference, we get the third. But how do we write our our general rule? Because a sub n tells me, I can ask you now, what is the 47th number? What's a sub 47? So if you look at this, each one of these is based on the one before it. Because if I have the first one, I can add 3 to it and get the second. If I have the second one, I can add 3 to it and get the first, or the third one, and so on and so forth. So the formula I have is I begin with my first one, plus n minus 1 times d. So we need two things to use this formula. We have to know the beginning term, and we have to know their common difference, d. So in our sequence, do we know our initial term? So let's say we want 1, 2, 3, 5, 6. Let's say I want to know the seventh number. So whatever's down here is n. So n equals 7. What is my a1? A1 is 1. And what's my common difference? 3. So let's plug all that stuff in there. 7. A1 is 1. Then I have 7 minus 1 times 3. So 1 plus 7 minus 1 is 6. 6 times 3 is 18. Add 1, I get 19. So my seventh number of my sequence is the number 19. Sure enough, it is. So once you have a sequence, if I ask you if it's arithmetic, we use this formula. How many variables are there in there? We have a sub n, a sub 1, n minus 1 times z. Right. This is a variable, this, and this. Because we don't know what those are. But in order to solve this, we have to have no more than one unknown. So we'd have to have 3 of these defined. Or if we have the sequence, we can find this and we can find this. And n is given to us. Because really, this one here is a resultant of this one. So really have three variables. Remember the two different types of variables we have? Independent, that's our x, and dependent, that's our y. George, you can't tell me what y is until you know what x is. So that's why x can be anything. It's independent. But once I define it, I plug it in there, and that tells me what y is. The reason I'm asking this question, because here's example 3. In an arithmetic sequence, with the second term 11 and the fifth term 23, find the 100th term. We know that a sub 2 is equal to whatever a sub 1 is plus its d. We also know the general formula is a sub 1 plus n minus 1 d. That's all we know so far. So now let's plug in what we know. The question says, in an arithmetic sequence, that means we have a common difference. The d's are the same. If the second term, a2, equals 11, and the fifth term is 23, so here n is 5. So a sub 5 is 23. So we have 23 is equal to a sub 1 plus 5 minus 1d. So if we take both of these equations and put them together, 11 equals a1 plus d, and 23 equals a1 plus 4d. What method do we know is solving these type of equations? This is called a system of equations. Because we have two equations with two unknowns. Any ideas? the theory is this. We have two equations and two variables. We have to get rid of one of the variables. So let me rewrite this equation so the bigger one's on top so it's easier to work with. If what I want to do here is I want to take the top equation and subtract the bottom equation. So I got 23 equals a sub 1 plus 4d and distribute that negative. So it's minus 11 minus a sub 1 minus d. Okay, but what I want to do, I want to get rid of the a sub 1. Since they both have a leading coefficient of 1, I need to make one of them negative. That's why I subtract them. 23 minus 11 is 12. The a minus a cancels. 4 minus 1d is 3d. So d is equal to 4. Why do we need to know d? So we can find a1, exactly. So I can use either one of these two equations to find a1. So it's easier for me to use this one, shorter one. So I use 11 equals a sub 1 plus d. 11 equals a sub 1, since d is 4. So a sub 1 is equal to 7. There's physical significance there. Remember, all I need is two of the variables to be defined. They're n, a1, and d. So the 100th term is, so it's 8 sub 100 equals a1 plus n minus 1 d. A1 is 7. 100 minus 1 times 4. Four times 9 is 36. 39. 396 plus 7 is 404. And that's my 100th term. No, 403. So you see, we have to sometimes go against the grain to go with the grain. So we have to do a lot of backtracking to find out what's going on. So that's an arithmetic sequence. Geometric sequences have what's called a common ratio. Because if you notice in our sequences, in arithmetic, in arithmetic, we add to get to the next one. So geometric, we multiply to get from the first. So from the first one to the second one, we multiply by 3. Second to the third, multiply by 3. So the common ratio is if we took these terms, 3 divided by 1, we get 3. 9 divided by 3 is 3. 27 divided by 9 is 3. That's the common ratio. We would take any two numbers that are in a series next to each other. Take the bigger one divided by the smaller one, and it should always be the same. Formularically, it's this: a n plus 1 over a sub n. So like we found the arithmetic sequence formula, in this one, instead of adding by this number, we now multiply by the common ratio, which is r, minus 1. Because if you look at, here's our geometry. So if you look at our series, 1, 3, 9, 27, 81, 243. Every one of these, this is my first term. That's A1. And the ratio is 3. So for the first one, if I multiply by 3, I get 3. If I multiply that one by 3, I get 3 squared, which is 9. If I multiply that one by 3, I get 3 to the 4th, which is 81. And so on and so forth. So 1, 2, 3, 4, 5. Let's see. A to the sub 6. I want to see if we get this number. So the leading term is 1. The common ratio is 3. 6 minus 1. So it's 1 is 1. So it's 3 to the 5th. Three to the 4th is same as 9 times 9. That's 81. 81 times 3 is 243. So it works. So a sub 6 is 3 to the 6 minus 1, which is 3 to the 5th. 3 to the 5th is 3 to the 4th times 3. 3 to the 4th is 81. 81 times 3 is 243. All right, let's look at this example. Find the nth term of this sequence. Actually, it would have been easier if you sat here instead of there all through the semester. So how do we know it's geometric? Take any pair of numbers and do what with them? No. Subtraction is arithmetic. This may be geometric. Well, yeah, okay, yeah. So 3 minus 2 is 1. Well, this is not 1. We see that because these are fractions. So now we check if it's geometric. Take the second term divided by the first. Check. Take the next two. 9 over 2 divided by 3, which is 3 over 1. Take the top, leave it alone, and flip the bottom. We get 3 over 2. Check. Take the next two. 27 over 4 over 9 over 2. 27 over 4. Flip the bottom. 2 goes into 4 twice. 3 goes into 27 3 times. So it's 3 over 2. Yes, so we have a common ratio of 3 over 2. And our first term is 2. So the nth term is a sub 1 r n minus 1. 2 times 3 over 2 n minus 1. And there's our formula for the nth term. If the first term is 3 and r equals square root of 2, find the 10th term. So we're looking for the 10th term. Our formula is a sub 1 r n minus 1. A sub 1 is 3. R is square root of 2. 10 minus 1. Since we're looking for the n is equal to the 10th term. Remember our conversion. From radicals to exponents. Whatever the root is goes on the bottom. Whatever the exponent is goes on top. So inside here, it's the same as 2 to the power 1/2. Because that's an invisible 2 there. Power to a power, you multiply. So it becomes 9/2. It's improper, so it becomes a mixed number. 2 goes into 9 4 times with 1 left over. If you haven't taken algebra, even if it may not be in your degree plan, I would strongly encourage taking college algebra. This will fill in all the blanks of the stuff that we just touched about in this one. So now what this means, this mixed number up there means I can have 2 to the 4th times 2 to the 1/2. So it's 3 times 2 to the 4th times 2 to the power 1/2. What is 2 to the 4th? 2 times 2 is 4, times 2 is 8, times 2 is 16. And 2 to the 1/2 power is the same thing as the square root of 2. 3 times 16 is 48, square root of 2, and there you have it. So you see, we're trying to cram 16 weeks of algebra into one small topic. It's just not going to happen. Right. Oh, sometimes we have what are called recursive series. Recursive series, arithmetic and geometric series are examples of them. It's where you use the previous answer to find your next answer. This is where you use the previous solution to find the successive solutions. Arithmetic, you have common difference, so you just keep on adding that same number to the previous one. And geometric, you keep on multiplying the previous one to the next one, and keep on multiplying. And sometimes You may have some that are neither arithmetic and geometric, but are recursive. This, a primary example of this is the Fibonacci sequence, or the series. I'll use sequence. Fibonacci. Italian mathematician. He presented a theory a long time ago that took until a couple of years back for us to solve it. And he gave it to us hundreds and hundreds of years ago. We just now proved it. You guys have probably heard this Fibonacci sequence. It starts off with this. And keep on going with there. The Fibonacci sequence, it takes the two numbers, add them together, you get the third. Add the second and third number, you get the fourth. Add the third and fourth, you get the fifth. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, and so on. So that's the Fibonacci sequence. There's no real pattern to it because it's not arithmetic, it's not geometric, it's just an equation out there. So that's whenever you hear Fibonacci, that's what it's talking about. Here's an example of how we can use math using variables to define what we're looking for. We have three sets. Oh. W stands for watermelon. C for cantaloupe. And F for flower. You go to the store, you purchase these two, it costs $8. You purchase these two, it costs $9. Oh, there. I'm sorry. And you purchase these two, it costs $7. How much does each cost? How would you go about looking for this? Well, let's jump in. The first thing we can do is pick any two together to combine. Let's say we combine these two. So we have watermelon plus cantaloupe plus flower equals $17. So we have watermelon plus cantaloupe plus 2 flowers equals $17. And remember, the watermelon and the cantaloupe have together to give you $7. So why is this important? Because it puts a limit on how big W and C can be. In other words, It has to. So in other words, a watermelon or cantaloupe cannot cost more than $6. So we know watermelon cantaloupe though cost what? It costs 7. Because we know that watermelon plus cantaloupe equals 7. So that one becomes 7. Subtract 7 from both sides. We know that 2F equals 10. So each flower costs $5. So looking at the first one, if the watermelon plus flour was $8 and the flour costs $5, then we know the watermelon is 3. If the watermelon is 3 from this equation, then the cantaloupe must be $4. Which brings us about to what we call the properties of equality of the equal relation. Or equal relation, singular. We have 3 types. The reflexive property, the symmetric property, and the transitive property. Reflexive like a mirror. Reflexive says A equals A. True. In other words, one side of the equal has to equal the other side. Symmetric. What does that mean? If we know that A equals A, then A plus C is the same thing as or if A equals B, then B equals A. No matter how we change it or arrange it, it's the same thing. You've probably heard the transitive property before. It says if A equals B and B equals C, then A equals C. That's the transitive property. Theorem 8-1 says the addition and multiplication property of equality. We begin by if A equals A. The addition property says if I add a value C on one side, then I got to add the value C on the other side, it stays the same. Or even more difficult to see, if A equals B, then A plus C is B plus C. A times C is A times C. That's easy to see. A times C is the same thing as B times C if A equals B. How can we test those? This is called the substitution property. If A equals 5 and B equals 5 and C equals 3, remember, A has to equal B. So A plus C is the same thing as B plus C. A times C is the same thing as B times C. Let's see if they're equal. 5 plus 3 equals 5 plus 3. They both equal 8. 5 times 3 is the same thing as 5 times 3. They both equal 15. That's the substitution property. Theorem 8-2 is the cancellation property. So in the addition part, if I subtract C from both sides, if I subtract the same value from both sides, then what's left has to be equal. If you take away the same amount from both sides, the resulting equation has to be the same. Whatever you do to one side, do the other. Golden rule. Likewise, in multiplication, if I divide C from both sides, then A equals B. Okay, I'm sorry. Yeah, I'm already gone 5 minutes over. So we'll pick up from here next time.